Okay, guys, for today's lesson, I'll give you a basic introduction to differentiation. And so I think specifically what we'll be going over is the constant rule, the power rule, the addition and subtraction rule, and also how to find tangent lines and the normal lines. So first off, for the constant rule, right, it states that for any number, like for a derivative of any number, y is equal to c. Then the derivative, or y prime, is equal to 0. So just a quick example, this is a very simple rule. Say we have a function y is equal to 5. The derivative of y prime is equal to 0. It's very simple. So I don't think we need to explain anything further. Just if it's a number without a variable, then the derivative of that number is 0. Now the power rule is a little more complicated, but at the same time is very simple. So what we want to know is for the power rule, there is a formula that we have to follow. So for this, you want to follow, so let's say there's a function f of x is equal to ax to the power of n. So a is a coefficient, a number in front of a variable x is our variable, and n is the power to which x is raised to. And so by the power rule, f prime of x is equal to a times n times x to the power of n minus 1. So what we're doing here is we're multiplying the coefficient by n and also subtracting 1 from n. Alright, so quick example. Say we have a function f of x is equal to 4x squared. Then you take 2, bring it down to 4 to multiply, and you subtract 1. So f prime of x will give us 8x to the power of 1, or just 8x. So that's very simple. Let's move on to our first example on just using the power rule. So to find the derivative of f of x is equal to 2x cubed, what we want to do is, so first you write f prime x, and that is equal to, we bring the 3 forward to multiply with the 2. So that'd be 3 times 2 times x, and then 3 minus 1 is 2. So if we simplify that, we get f prime x is equal to 6x squared. And that would be our answer. Right? Very simple. Let's just get another example just to be sure. So for this one, it wants us to find f prime of -1 and f prime of 0. So the first step we have to do before we even reach a and b is we want to find the derivative of f of x. And so for this one, first I'm going to rewrite f of x into, so that it's like a fraction multiplied by x to the power of 4. Right? Now we can just do the same thing, get 4 and multiply by half. So f prime of x is equal to 4 times half, which is 4 divided by 2, which equals to 2, times x to the power of 4 minus 1, which gives us 3. So this would be our derivative. Now it wants to find the f prime of -1. So that means we plug in -1 for x in our f prime. So f prime of -1 is equal to 2 times -1 to the power of 3. I just pulled this equation, or this function, and brought it here, and plugged in -1 for x. And now -1 to the power of 3 is -1, and then -1 times 2 gives us -2. So our answer would be -2. So now we do the same thing for 0. F prime of 0, we take this function, and so f prime of 0 is equal to 2 times 0 to the power of 3, which is going to be 0. So that's also our answer for B. Now, this is where we have to know how to find the equation of the tangent line and the normal line. So first step, before we go on to A and B, what we want to do is first we just want to find the derivative of this function. So f prime x is equal to, you bring 2 to the front and multiply with 3, which is 6, and 2 minus 1 gives us 1, so 6x. So this is our derivative. Now, what we want to do for the tangent line is, first you want to find the slope of the line. And to find the slope of the line is, first you have to plug in -2 for x. So the slope of this tangent line would be 6 times -2, which is -12. Then you want to find the point on the normal graph. So we only have the x value. We also want to find the y value. And to do that, you just plug in -2 for f of x, so the regular equation. -2 to the power of 2. And so this gives us f of x. So -2 squared is 4 times 3 gives us 12. So now we use our formula. So that would be y minus y1 is equal to m, or the slope, times x minus x1. And so y1 is our point. So that's 12 that we found here. So y minus 12. Our slope is -12. And we keep x, and then minus, and we know our x. So that would be plus 2, because it's minus -2. So this would be the equation of the tangent line at x equals -2. This would be our answer. And now for the equation of the normal line, it's the same thing except it's perpendicular to the tangent line. And basically when we have a perpendicular line, the slope of that line is the negative reciprocal of the slope of the tangent line. So what that means is the slope, which is m. So for the tangent line, it's -12. And for the normal line, we find the negative reciprocal. And the reciprocal is just 1 over that number, so it'll be 1 over 12, well, negative. But since we're finding the negative reciprocal, it'll just be 1 over 12 for the normal line. And so now we can just rewrite the other equation. So 1 minus 12 is equal to 1 over 12 times x plus 2. And this would work as our answer, right? Or you could just add 12 on both sides to get y equals to 1 over 12 times x plus 2 plus 12. So this also works. And so this is basically how you find the normal line and the tangent line. Next up, we're going to be going over the sum and difference rule. And so this is also very simple. All it's saying is that when you're finding the derivative of, say, something that's f of x plus or minus g of x, then that would equal to just finding the derivative of f of x and adding it or subtracting it with the derivative of g of x. So basically separately just finding the derivative and adding it. Right, so it's very simple. You just, the separate parts, you find the derivative of them and you add or subtract. So let's look at an example. We have to find the derivative of f of x equals x cubed minus 4x plus 5. And so in this scenario, we have to individually find the derivative. So for x cubed, the derivative, you would bring down the 3 and subtract by 1. So we'd get 3x squared. For negative 4x, or for just minus 4x, we will bring down the 1. So 1 times 4 gives us 4. And 1 minus 1 gives us 0. So x to the 0 is 1. So we have no more x. And then 5 is a constant, so that would be 0. So our answer would be 3x squared minus 4 for using the addition or subtraction rule. And just another example is to solidify the addition and subtraction rule. So for this one, I'm just gonna, before I find the derivative, I'm just gonna rewrite it so it's more clear. It's -1/2 x to the 4th plus 2x cubed minus 5x. Alright, now if you find the individual derivatives, you bring the 4 and multiply with the -1/2 and subtract by 1. So 4 divided by 2 is 2, so -2x to the power of 3, because 4 minus 1 is 3. You bring the 3 down. 3 times 2 is 6. 3 minus 1 is 2, so x to the power of 2. You bring the 1 forward, multiply by 5, and you subtract by 1 to get 0. So you get negative 5, and x to the power of 0 is 1, so 5 times 1 is 5. And so this would be our answer. And that would be it. So this is pretty much all we need to know for the basics of differentiation and like the intro. So all you just need to remember, I think the most important one is this rule right here. You need to remember the power rule, because this is what you can apply to pretty much everything. The constant rule is very simple, just if it doesn't have variable, it's equal to 0. But the power rule tells us that we need to bring the power, so, 4x squared, bring the 2 forward, multiply with the 4, and then you subtract 1 from 2, and then you get 8x. And so that is pretty much the whole basis of our rules of differentiation. And so thank you for watching this video. If you have any questions, please leave a comment down below, and I will see you guys later.